we've talked about ionic compounds, now we're going to talk about molecular compounds. Molecular compounds, the formula cannot be figured out just by looking at charges because there aren't any ions. And you can have lots of different combinations using the same two elements. And so the example here is with nitrogen and oxygen. There are 6 different compounds that form between nitrogen and oxygen. And so each of these has to have a unique name. And we want that name to suggest the formula. So what we do is we use numerical prefixes in the name to tell us how many there are. Students tend to like this method because it's a little more intuitive, and then you try to use it all over the place. You can only use it with the nonmetals. Okay? You can't use it with ionic compounds. So here are the prefixes, and those should look familiar, right? Those are the same as the prefixes for the hydrates. The only difference is there's no half. So let's remember that molecular compounds in Chem 1A are composed of 2 nonmetals. We're going to list the more metal-like element first and the less metal-like element second. And the only reason I'm telling you that is because some of you wonder, well, why is it CO2 and not O2C? And that's the reason. You don't ever really need to predict that, because if we give you the name is going to have the elements in the correct order. You write them in the same order for the formula. Or going the other way, it's going to be the same. So I'm not going to try to trick you with this thing. So we're going to have a prefix and the name of the first element. And so this element is kind of acting like it's a metal, right? It's just using its full element name. And then the second one is acting like the nonmetal in an ionic compound where they get married and the nonmetal changes her name, right? So here, the ending of that second element's name gets changed to IDE. I-D-E. So we're going to have a prefix telling how many of those. Now, sometimes we don't write the word mono or the prefix mono. So typically, if mono would be used for the first element, we're not going to write it. And so you may see a little inconsistency in where mono is used or not, and we're not going to get hung up on that. But if we look at this one, NO2, well, the first element is nitrogen. And if you're going to put a prefix on it, it would be mono-nitrogen. But we usually skip that. And then the second element is oxygen in a relationship, so it's oxide. And because there's 2, it's dioxide. Okay? There are 2 compounds, molecular compounds, that always use their common names. Water and ammonia. So water is H2O. You just need to know that. And NH3 is ammonia. Could you name these using the system? Sure. Dihydrogen monoxide. And so, you can mess with people. We drank dihydrogen monoxide in chemistry lab today. She said we had to. Right? Oh, scary. Yeah, we went and had a drink from the water fountain. Ammonia, you could call this nitrogen trihydride. Okay? So that's one where I might try to trick you. Okay? So NH3 is ammonia, and water is H2O. Let's name this compound N2O5. Well, what's the name of the first element? Nitrogen. Nitrogen. And how many of them are there? 2. So what's the prefix I'm going to use? Di. It's a little bit backwards, isn't it? Because in the formula, the number comes after, and in the name, the number comes before. They didn't consult me on this. I would have advised them differently. And then this element is oxygen, but she's being the female in this relationship, so she's going to change the ending of her name, as if she was an ion, even though she isn't. So that would be oxide, right? And then we need a prefix to tell us how many. Penta. Pentaoxide. We sometimes end up with these double vowels in there. Sometimes we'll drop the vowel on the end of the prefix, other times they don't. I will not try to trick you on that one. Write the formula for phosphorus tribromide. Phosphorus is P, right? How many phosphorus atoms are in this molecule? 1, because it doesn't say any other number. It doesn't say monophosphorus. But if there was 0, we wouldn't have the name in there at all, right? My friend the choo-choo train. Okay, what's the second element? Bromide. Yeah, bromine. So Br, and the tri tells me there's 3. PBr3. There's not as many of these binary molecular compounds, and they're pretty straightforward. What you need to remember is don't use these rules for things that are not 2 nonmetals. 2 nonmetals. So there's a group of molecular compounds that have a special system of naming, and these are called acids. So an acid is a molecular compound, but when you dissolve it in water, it ionizes and makes hydrogen ions. So that means that acids are composed of hydrogen and 1 or more other nonmetals. The hydrogen's always written first. Whatever else is written second. So if we look at this, HCl, well, that's 2 nonmetals, right? Molecular compound. When it's dissolved in water, it forms ions, and so when it's dissolved in water, we name it as an acid. If it's not dissolved in water, we would name it as just a molecular compound. So that would be hydrogen monochloride, or perhaps hydrogen chloride. What we're going to do is we're always going to name them as acids. So anything that starts with an H is an acid, and we're going to name it as an acid. Okay, again, I'm not going to try to trick you with this. So, the way we'd write that formula is HCl aqueous. HCl can also be in the gas form, but I'm not going to ask you about that. But like on the worksheet and maybe homework problems and stuff, you'll see AQ after all of these acids. And that means we need to name them as an acid. But I always want you to name anything that starts with H as an acid. Okay. There are compounds that start with H that don't dissolve in water and are not acid, but they're not going to show up for us in Chem 1A. We'll just leave them out. We can kind of simplify things here and leave out some of the complicated exceptions. So acids have some common characteristics. They taste sour. So have you ever tasted a lemon? Ooh, sour, right? Or sour candy, right? Sour Patch Kids. There's actually acid in that sugary coating on the outside, and that's the really sour taste. Acids will dissolve many metals. Not all of them, though. Zinc, iron, and magnesium will dissolve in metal. Here's an illustration of zinc metal dissolving in hydrochloric acid. The formulas for acids generally start with H. In Chem 1A, they always start with H. It gets a little complicated after you get through 1A, but for now we can keep it simple. So HCl, H2SO4, the H in front. So we learned that if the first element is a metal, it's what kind of a compound? Ionic. If there are two nonmetals, it's molecular. We can use the prefixes, yay. If it starts with H, I know hydrogen is a nonmetal, but if it starts with H, it's an acid. So there are acids that have oxygen. These are called oxyacids, and acids that do not. Your book calls them binary acids. And we have different names for those. So the binary acids are going to use the prefix hydro to represent the H at the beginning of the acid. And then whatever the other element is, you're going to take that element name and change its ending to ic and slap on the word acid at the end. So name the acid HF aqueous. So this is a binary acid. There's two elements. There's no oxygen. So for the H, we're going to write hydro. And F is fluorine. So we're going to change the ending of the name to fluoric. And this is one word, hydrofluoric. Oh, that didn't go very well. Hydrofluoric acid. 2 words. And then if we need to write the formula, hydrosulfuric acid. So what 2 elements are in this acid? Hydrogen and sulfur. But it doesn't tell us anything about how many hydrogens and how many sulfurs. But acids ionize when they're put into water. So we're going to use the ion charges of hydrogen and sulfur to figure out the formula. So what charge does hydrogen have as an ion? +1, because he's in group 1. And what charge does sulfur have as an ion? 2-. So we're going to need 2 hydrogens for 1 sulfur, and then ideally you'd put AQ behind it. Any questions? Yeah.
When it is asking us to make the compound, we put AQ, but when we're spelling the compound, we just put acid.
Yes. Yep. So when you're looking at the name of an acid, they're easy to recognize from their name. It always has acid at the end, right? When we write the formula, this putting the AQ there is kind of a finicky thing, right? Technically, you should put the AQ there. So I'm going to do that, but I'm not going to mark you wrong if you don't. Okay, so I'm going to demonstrate the proper way, but I'm going to let it slide also. So the oxyacids. The oxyacids have an oxyanion in them. Those are the things we just learned about, like chlorate and sulfite, hydrogen phosphate, all of those guys. So for the name of the oxyacid, we're going to use the name of the oxyanion, and we're going to change the ending and throw the word acid on it. So you look at the name of the oxyanion. If the oxyanion ends in ate, like nitrate, then you change the ate to ic acid. If it ends in ite, like sulfite, then you're going to change the ending to us, sulfurous acid. Let's do it this way. So again, there we have two things, and two things we have to remember how to put them together, right? We have ate and ite, ick and us. So we need to figure out how to do that, how to remember it. So, oops, is the white mouse ate icky cheese. I've heard this one used a lot here at Fresno City College. Well, how does that help us? Ite and us go together, white mouse. Ate icky cheese. Ate and ick go together. The one that I've always used, which I think is, nice because it's stranger. Rick ate him before he could bite us. But again, you have the ite and the us, the ick and the ate. So you got to pair those up. Okay, let's name this acid. Well, it said acid there, and this is naming oxyacids, but it also starts with an H. So we know it's an acid because it starts with an H. So let's cover up the H and look at what is the other part. This is an oxyanion. What's its name? So we want the name of the oxyanion, and then we'll change the ending.
Oh, so nitrite?
It's nitrite. Nitrate is NO3. So this is the nitrite ion. So we're going to change ite to us, like white mouse or bite us. And this becomes nitrous acid. We're not going to put the hydro on the front. That's only if there's no oxygen.
But if we did, it wouldn't be like bad.
Well, hydronitrous acid, people would say, but that doesn't exist. But if you said hydronitric acid, well, hydronitric acid is a binary acid, and that would be H3N,
No, it's not so
aqueous. Whereas nitric acid is from nitrate, and so that would be HNO3. And, this is one of those places where you have to be precise. Just like with somebody's email address. You type an L instead of a 1 and they never get it. And we live with that. We're okay with that. You miss one digit on the phone number and you get somebody else. It's the same thing here. We have to have it just right because there's other things that are very close. Okay, let's do the other way. Write the formula for perchloric acid. So the oxy acids are based on the oxyanions. So perchloric, the ick goes with ite or ate? Ate. So this is an acid containing the perchlorate ion. So the formula for the perchlorate ion is one more oxygen than chlorate. So Cl O4 with a -1 charge. That's the perchlorate ion. The charge is important because that's going to tell us how many hydrogens it's going to have. So this will need one hydrogen to be a neutral compound, HClO4 aqueous perchloric acid.
Okay, so this one you put the H.
Well, it has the H in the formula. This one also has the H in the formula. I just covered it up so we could focus on this. But we're not using the hydro prefix,
Oh, okay, okay.
okay? Any other questions? We already did this, but here's the instructions. So when you have the acid name, it's got acid in it, and that tells you this is an acid, and so the first element's going to be hydrogen. So we're going to write the formula as if it was ionic, even though it's a molecular compound, but it forms ions in solution. If we see that hydro prefix, then it's just hydrogen and another element. If we don't have the hydro prefix, then it's an oxyacid, and its name is going to be based on the oxyanion that's present, or its formula. Okay, so if it ends in ick and ate go together. Us and ite go together. We're just going in the opposite direction. So write formulas for these acids. Hydrocyanic acid. Is that an oxyacid? No. But thank you for guessing. I appreciate that. When it starts with hydro, it's not. It's just a binary acid. Okay, so this one doesn't have any oxygen in it. So the hydro, that stands for the H. And then cyanic, that's not an element, is it? There's a polyatomic anion called cyanide. Yeah. And cyanide is Cn minus. This is why I don't like it that they call these binary acids, because this falls in that category of naming, but there's 3 elements in it. So I prefer to think of them as oxyacids and the other kind, right? So we've got the hydrogen ion and the cyanide ion, and then we're going to put them together as if they were ionic, so the charges will add up to 0. Okay? Phosphoric acid. Oxyacid or other? Oxyacid, because it doesn't say hydro. So phosphoric comes from a polyatomic anion. Ick and 8 go together. So this comes from phosphate. And you might ask, well, why isn't it phosphic or phosphorate? I don't know. Sulfur does that too. The part just kind of comes and goes whenever it feels like. I'm not going to try to trick you on that. So phosphate, what's the formula for phosphate? PO4 3 minus. And it's an acid, so the cation is hydrogen ion.
Oh, but should we aqueous at the end of it, or?
Well, I'm not done yet.
Oh,
I'm just writing the 2 ions here with their charges so that I can see how I need to put them together. We need 3 hydrogens. So it's going to be H3PO4 aqueous. Because all of the acids have the cation hydrogen with a +1 charge, the number of hydrogens is just the number of the charge. This is 3 minus, it's going to have 3 hydrogen. 1 minus has 1 hydrogen. 2 minus has 2 hydrogens. How about this one? Hypochlorous acid. Oxyacid or other kind?
Is
This
this
is
hypo?
tricky.
Oh.
Hypo and hydro. Really
Hypo is a low one.
close.
Oh, it's an oxy.
Oxyacid. I know, right?
I just remember when you said hydro, I was like, oh yeah, it's oxy.
Yeah, hydro, representing hydrogen, that's the other kind of acid. But this is hypo, which looks a lot like hydro. You know, just take this P, tip it upside down and around, it would make a D, and only forgot the R. So we're going to change this us ending to ite. So this is hypochlorite ion. So we need the formula for hypochlorite ion. That's going to be ClO with minus. Chlorate is 3 oxygens. The light version is 2, and below the light version is 1. And a hydrogen ion, and so what's the formula? HClO, aqueous. Mm-hmm.
Oh, I don't need the minus there because it's not necessary. Because it's the formula.
Right,
is
when we write the formula for a compound, we leave all the charges out. Because isn't it complicated enough? Because like here, you start putting the charges in there, and you know, things get messy really fast. And it's not necessary. So we're trying to convey a distinct meaning with as little writing as possible. Because, you know, otherwise we could call this the acid that has 3 hydrogens, 1 phosphorus, and 4 oxygens in it. Yeah, you don't want to write that out in a chemical equation. So, you know, this is just a concise way of doing it.